Hey guys, my name is Kevin, and I want to talk to you guys a little bit about machine learning. I know it's been all over the news, machine learning, neural networks, and I wanted to kind of bring it home. I've been working with it a lot over the last 2 semesters, and kind of drill down what it is, what it isn't, and what it can and what it really cannot do. So first, what is machine learning? All right, machine learning is a subset of computer science dedicated to pattern recognition and, by extension, exploitation. So using patterns and data to our advantage, right? And a good quote for this is, machine learning gives computers the ability to learn without being explicitly programmed, which is kind of in the name of it, right? But this represents a huge paradigm shift for computer science people today. It's not as much people writing code, it's humans supplying data, which is huge. But what isn't machine learning? All right, machine learning is not magic. All right, it's statistics and linear algebra. Anyone who says something different is telling you something. Machine learning is not artificial intelligence. It's not iRobot. Machine learning is not going to take over the world. It's not what this is. And it's rarely exactly precise. We can't predict stocks. We don't know the weather exactly. All right, machine learning is good, but it's never quite exactly there. So with machine learning, what are some applications you can do with it? All right, we have classification. So this is a machine learning algorithm that says, based on the billion spam emails I've looked at previously, is this what I'm looking at now? Is this spam? That's how your spam filter works. Prediction, right? Based on the billions of weather records I've looked at, given the weather records today, is it going to rain tomorrow? That's how weather forecasting works. Imitation, based on what I just watched the human do, or what I've been watching the humans do, what should I do now? This is a lot how they're training self-driving cars. Pattern recognition, this is probably one of the biggest things. Given this enormous pile of data, what can I do with it? Okay? So machine learning is incredibly good, and it can learn some incredibly complex patterns. For example, handwriting. Machine learning has cracked handwriting literally 2 decades ago. When you write a postcard or when you sign a check, no human is reading that and typing it into a computer. Machine learning has learned to recognize human handwriting and transform scribbles like my handwriting into human readable text. Go. Or other games. So you guys heard Google's DeepMind beat the world champ 4 to 5 times. That was done with machine learning. This is kind of hard to describe. This is a UMD lab. It's a little hard to see. But they're teaching a robot how to cook by letting it watch YouTube videos and just letting it follow along. And it can do it. It can make drinks. Google Translate. Google Translate is a machine learning application. Nowhere in Google Translate does it have a little book that says hola equals hello. It says, based on the billion articles of Spanish and English translated text, I've seen hola next to hello like 99% of the times. So when you type in hello, I'm going to spit back hola, because statistically that's what you want to see. Tumor detection, or any genomics research. This right here you're seeing is a machine learning application to detect a tumor. Right? This is a tumor that the humans missed, by the way. The issue is machine learning is so good at recognizing patterns, often it can find patterns you didn't want it to find. Or there's the wrong pattern completely. For example, Microsoft's Tay. Which you guys heard of this? Microsoft released Tay, a chatbot, about a week or 2 ago on Twitter. And within 13 hours of learning from the Twitter sphere, it turned into a huge racist bigot. Watson, a few years ago, IBM researchers wanted to make Watson more lifelike and be able to speak better. So they just let it crawl around on the internet. I had stumbled across Urban Dictionary overnight, and when they came back in the next morning, it was cursing at them, every single answer. It cost IBM tens of thousands of dollars to cut all that out. Nest, when they were first training their smoke detectors, one of the features they wanted was to be able to, you wave your hand, and it would shut off. It's a false alarm. But all it learned was to shut off at any sign of motion. So I'll let you just think about what could go wrong with a smoke detector that shuts itself off at any sign of motion. Or Siri, when Siri first came out, so the natural language processing wasn't quite right. I couldn't differentiate between asking for food and an illness. Right, now you might be looking at this and be like, well, I mean, the algorithms are totally fine. Like, we've got tons of amazing successes. Like, clearly these guys are just doing something wrong, right? The data's bad. So we're going to go through a little example that kind of shows, like, this is a lot harder than you think it is. So I'm going to show you 2 classes of pictures. Okay, here's class A. I'm going to train you guys. You're the machine learning application. I'm not going to tell you what pattern I want you to find. I'm just going to show you 2 classes of pictures. You guys are going to learn the pattern, and I'm going to show you a picture you've never seen before, and you're going to tell me what class it is. All right, so here's class A. I hope everyone gets a pretty good idea what's going on with class A. Here's class B. Right, not too hard. We've got a pretty good idea what's going on with class B. Here's class A. Here's class B. What class is this? Someone can just shout it out. And everyone sees this and says A. The pattern I wanted you to find was, is the background in focus? This is class B, guys. Now, this is actually a real world example. The Pentagon a few years ago tried to train a neural network to detect enemy tanks in camouflage. The issue was all the pictures they had of our tanks were crystal clear to feed a beautiful line of sight, and all the pictures they had of enemy tanks were blurry and far away. So all the algorithm learned to do was look for a blurry picture and say enemy tank. There's a few limits of machine learning, and those examples kind of drilled them home. First off, machine learning can't replace game theory. This is like a kind of weird statement to say, because like you see things learn how to play chess or learn how to play Go. Although neural networks may be the powerhouse behind it, you still need game theory to make it all work. Machine learning is really only as good as the input data you give it. For example, I didn't give you guys quite the right data for that Class A, Class B example, even though you're pretty smart. It's also rarely exactly precise, like I mentioned before. But one of the biggest things is it misses the meaning behind things. At the end of the day, a lot of this is just statistics and linear algebra, right? And so to drill home the real background behind neural networks can't understand meaning. I'm going to talk about briefly recurrent neural networks. All right, these are a special type of neural network designed for prediction. So based on previous unstructured data, make more of it. So what you're seeing here is a neural network generate house numbers. People gave it a couple 100,000 pictures of house numbers and said, make me some more. Now, this neural network has no idea what a house is, doesn't know what a number is, it has no idea what it's doing. It's just generating similar pixel diagrams to what it's seen previously. But amazingly, if you look at this, all the ones on the right, you have no idea that this was just generated. Those houses don't exist. But this has some amazing applications. You can feed it the whole works of Shakespeare and ask it to write Shakespeare. And as Shakespeare writes, it's garbage, but it looks like Shakespeare. So to bring this home, I'm going to talk a little about someone took this recurrent neural network and gave it hundreds of thousands of recipes and said, write me a cookbook. Okay? And I'm going to show you what some of those recipes have generated. First, we have country dip cookies. Okay, this yields 6 servings. Well, somehow. This is things to make pasta spread with sauce. Unfortunately, it only serves 3 when you're done with it. Now, when you look at this, you may be laughing. But this is incredible. Right? No one told the neural network, you have to say title with a title. No one told it, give a yield. It learned that when you write a recipe, you should give it a title. Usually that title is all caps. That you should tell the person reading it how many servings it makes, even if it makes no sense. A lot of times it cites itself. It says this recipe was by, and just hallucinates up a name. It learned the format of how ingredients come in and the units we use. None of this was programmed. It wrote this recipe character by character, which is amazing, but it's still incredibly, frustratingly stupid. Here's another one. Brock, plant, brock, stuffed bland for 1. 16 servings worth. I don't know what about this you want to eat. One of the fun things about this algorithm is it noticed salt came up in so many recipes that it started adding salt to a lot of its own. But more than once. It didn't learn that you could just only, like if you were going to add salt, just put it once in the ingredient list. It often generated recipes that required salt 6 or 7 times. Different amounts. It's amazing. Here's the last one I'll leave you with. Cheese salad and sauce. 4 servings. It also learned some amazing things like you can offer substitutions. If I don't like hot water, for example, I can substitute with salt. Water, braided, always important. This is the dessert, by the way. So, machine learning is incredibly powerful, and something that's definitely going to be more and more pervasive in our lives and the algorithms we write going forward. But at the end of the day, we can't lose sight of the fact that it is just statistics, and it does miss a lot of the meaning behind things. We can't lose the human aspects of the programming. So, thank you. Does anyone have any questions?